So this talk is about storage and digital transformation. And how many of you have heard the term digital transformation floating across your inbox over the past 6 months? And how many of you thought, I haven't used one of these in years? What are they talking about? What does this even mean? In my life, things have been pretty digital for a really long time. So this word always threw me for a bit of a curve when I heard it, because I'm thinking, this isn't a new idea, But that's not really what they're talking about. When people say digital transformation, they're not talking about throwing away old technology. That's not what they mean. They mean speed, right? They mean how fast can you get your services to market? How fast can you process an order? How fast can you hire an employee? How fast can you do something? Are you thinking about the possibilities of technology as part of your process, or are you thinking about it as an afterthought? So it's not about arcane technology versus new. It's about moving quickly. And I think when I start to pull apart what that actually means for an organization, it means a few goals and a few principles. And the first is a goal of agility and elasticity. That's what we really mean when we talk about digital transformation. We're trying to be more agile, trying to respond more quickly to demands when they are new. We're trying to be able to respond to success when it happens. That's what elasticity is good for. It's good for responding to success when it happens. And that's what we mean by digital transformation. Can we leverage technology to bring services to market more quickly? And can we do it to capitalize on our success more quickly? That's what it means for a company to go through digital transformation. So the goal is agility and elasticity. So when we think about technology, what does that actually mean? There's a couple of principles that I think it means. If you have different ideas, shout them out. But for me, one of them means distributed deployment. In order to have that agility and that elasticity, you need to be able to deploy your technology across anywhere. It needs to be in multiple data centers. It used to all be in one data center. That's the has not gone through digital transformation approach. Everything's in one data center. The modern approach is multiple data centers across those, across the public cloud, across CDNs. Deployment is everywhere now. It's not concentrated, it's distributed. So that's one principle of digital transformation. Another is that what used to be a good idea was finding the best piece of hardware for your task. That was the challenge before. I have a job to do, and let me find all the hardware I need to do that particular job. And I want to make sure that the hardware does that job to a T, and it's bespoke for it, because hardware is expensive and time is not. But it's not that way anymore. These days, time is expensive and hardware is not, at least not so much. And so people are using generalized hardware. And instead of buying boxes of all shapes and sizes and hardware of all shapes and sizes, people are generally trying to buy the same kind of hardware and run stuff on the same kind of hardware. This is something that's happening as companies go through the digital transformation. They're realizing, I don't want a different procurement process for every little piece of my data center. I want to try to make that as unified as I can. So a second principle is generalized hardware. Distributed deployment on generalized hardware. Another principle, I think, is decentralized control. This is kind of a consequence of the other two, but once the technology is everywhere, and once agility becomes more important than anything else, you want to be able to give control to as many people as you can, right? So people who consume infrastructure now are not just operators or administrators. They're all kinds of people. They're line of business owners. And digital transformation means embracing platforms, things like OpenShift, things like OpenStack, things like the public cloud, that take that power and put it into the hands of the people who are doing the work, in different business units around a company. So it's decentralizing control. And I think that summarizing all of this up, and I love this illustration. I've been using this for years. And when you see it now, you're like, what the hell does this mean? Most people's IT operations kind of behave like this. It's a big whale in your data center. And you start thinking, well, all right, now I have had a bunch of success, and I need to be able to serve more infrastructure, so I need a bigger whale. So forget this whale, let me buy a bigger whale. I think infrastructure should work more like a school of fish in the shape of a whale. You should be able to add fish and remove fish. If a disease comes along and eats half your whale, you have a dead whale. If a disease comes along and eats half your school of fish in the shape of a whale, you have a smaller school of fish in the shape of a whale, right? And I think that this is how people want to use their infrastructure these days. They want to have a pool of infrastructure that they can add to and subtract from that grows as their business grows. And I think flexibility is absolutely crucial. So everything in the data center, obviously, as companies are grappling with digital transformation, and I'll talk about storage soon, I promise. I know you're waiting for it. everything in the data center is changing. Development models. We used to build stuff with waterfall models, and then we became more agile. Now DevOps is the way to get software built and deployed. The application architecture used to be monolithic, then went to end-tier. Now microservices is kind of the way things are being done. You're seeing a sort of parallel set of trends here. Deployment and packaging, bare metal was how it used to be done, then virtualized, now containerized. It's sort of evolving, becoming more efficient over time. Application infrastructure used to be run in the data center, then it was hosted, now across the hybrid cloud, public cloud, private cloud, that sort of thing. And so we get to storage. Well, it used to be scale up storage. Then we started to do scale out storage to a certain extent. But what's next? Like, what is the storage answer to DevOps microservices and containers on the hybrid cloud? What's the storage answer? Well, that's what I'm going to talk about today. So all this has been an intro. So the first section is, what makes storage challenging, right? Before we talk about what I think the solution is, I'd like to talk about what makes storage hard. Because storage is a particularly difficult thing in the data center. So this is a series of kind of truisms about storage, you know? First one is that storage is essential, you know? I mean, I know this is a crazy thing to say, but nothing we put in the data center works without storage. It's absolutely essential. Everything you deploy needs storage. Everything Red Hat sells needs storage. Everything you deploy needs storage. So it's absolutely essential. An operating system and storage are kind of the two things that are essential for every workload, no matter what it is. The second is that data has gravity. Has anyone heard this phrase? Raise your hand if you've heard this phrase, data has gravity. So I've actually been corrected on this phrase once. Someone said, no, data doesn't have gravity, it has inertia. What this phrase means is that once data ends up in a storage system, it's really expensive to move it, right? It's heavy. Once it finds its way onto a hard drive, it's a pain to get it onto a different hard drive. So people correct me and say inertia, but I'm like, yeah, but once you get data moving, it's not hard to stop it. You know what I mean? So I think it's gravity. And the thing about it that also means gravity to me is that once that data is on that hard drive, it attracts the workloads to it, right? So it actually has a gravitational pull. It pulls things to it. And as a consequence of storage or data having gravity, storage solutions tend to be sticky. Once somebody buys a storage solution, if you're deploying OpenStack and you say, I don't want to worry about storage now, I'll just use my local disks for now and just, you know, whatever, I'll use a NAS on the back end, you'll end up doing that, you know, because once it's there, it's there. Nobody deploys a big infrastructure and then comes back 6 months later and deploys storage underneath it. That doesn't happen. So once it's been chosen and deployed, it's really difficult to choose something different. Another truism about storage. A third is that there are a bunch of different kinds of storage. Maybe I should ask, how many of you are storage practitioners in the room? Oh, too many. Oh, okay. Anyway, there's all kinds of different types of storage. Storage is not a one-size-fits-all thing. Sometimes it looks like a hard drive. Sometimes it looks like files and directories. Sometimes it looks like objects in an unstructured sort of, you know, object storage cloud in a cluster. There's a bunch of different kinds of storage. And you know, as much as we like to think storage is storage, it's really not. And each of these are used for completely different purposes. It's another truism about storage. Another one is that storage needs vary. They vary all the time. Not all workloads come in the same size and shape. Things that are platforms like OpenStack and OpenShift, totally unpredictable, right? Like, you don't know what kind of workload's going to be run on top of those. You have to be ready for anything. Something like backup, if you're looking for a backup target for storage, it needs to be low cost. It needs to be what we call cheap and deep, right? It needs to be as much storage for as little cost as possible. Things like a data lake or a media lake require that elasticity I was talking about in performance. And so storage is not a one-size-fits-all thing. A lot of people who buy storage appliances are buying one of a choice of 5 or 10 storage appliances. They're sold as a one-size-fits-all thing, but they're not a one-size-fits-all thing. Another thing is that, sort of related to the distributed control I was talking about earlier, storage admins are changing. A traditional storage admin generally worked on a team that specialized in storage. You know, you'd work on a team, and my job is to provide file services. You know, I'm seeing less and less of that, and more of modern storage admins who are working on big platforms and have to look at the whole thing, right? They're deploying a cloud, and they need to think about compute and storage and networking and the whole thing all together. This is something I'm seeing. So for those of you who raised your hand and said that you were a storage practitioner, how many of you focus exclusively on storage? Okay, a couple. Yeah, I think that's sort of That's not especially at Red Hat Summit, it's not very surprising because we're kind of we do a lot of different compute things as well. More storage truisms. And this is starting to, I guess, go into opinion a little bit. Appliances aren't always enough, particularly for something like OpenStack. Appliances aren't enough. Appliances are super convenient. They have all this. It's not easy to do distributed storage that's durable, and all that is very complicated. And that complexity is hidden from a user with appliances, right? A lot of decisions have been made for you, and they're optimized for convenience. And that is fantastic for many, many, many workloads. However, they are closed systems. They lead to some vendor lock-in. That happens from time to time. If you buy, a bunch of appliances from one storage vendor and you need to get them serviced, or you need to expand them, you need to build them, you generally are going back to the same storage vendor. And if you want to continue using that appliance, you have to go back and continue paying, maintenance for it and et cetera. And that lock-in tends to manifest itself in a price premium that is it's more than the constituent parts. What you pay for an appliance is way more than the actual hardware that's in the appliance. So this is one reason why appliances aren't enough. I think that the big reason is this flexibility thing. You hide complexity, you also hide flexibility. That's just a trade-off. So appliances are great, appliances aren't enough, not for everything. Public cloud storage, similar, also kind of not enough. It's really convenient. Pricing is pay-as-you-go, which is awesome. It's awesome if you need to get something up and running right now, but if you want to run on it for 10 years, it gets to be more expensive than you would want it to be. Yet this is the fastest growing segment of IT storage budgets. This is where more storage money is going. The convenience is very powerful, right? Again, it still is also built with proprietary technology. The lock-in here, though, this is probably a bit poorly stated, because it's not the proprietary technology that creates lock-in in the public cloud. It's the actual location of your data and how much it costs to get it out. That's what the lock-in comes from in public cloud storage. So as a result of all of these truisms, which I hope aren't terribly disagreeable, I think that the industry is really rethinking storage. We did some research last year and talked to folks who sort of make IT decisions around storage, and 38% of them reported that inadequate storage capabilities was one of their top 3 weekly pain points. So of all the things that keep them up at night, 1 out of 3 nights it was storage. Or maybe a little less, because it's probably rank ordered. But 38% reported that. I think that's interesting. More interesting, though, is that 70% of those same people admitted that their organization's storage can't cope with tomorrow's workloads. They were asked, tomorrow, like next year, you know what you have to be able to do. Can you do it right now with your current storage? They said, no, absolutely not. 70% said they can't do it. And unsurprisingly, 98% believed a more agile storage solution could benefit their organization. I'm wondering who these 2% are. That's what I'm wondering. Like, who doesn't want a more agile storage solution? Anyway, 98%. I'm sorry? They're retiring soon. They're like, I don't want the hassle. Yeah. So I believe this software is the answer. This is what I believe. So let's explore this a little bit. How many folks are familiar with software-defined storage? Most of you. See, much more high-level talk. So we went through this. At the end, what's happening in storage? Scale up, scale out. Well, we believe the answer is software-defined storage. We think that, if the development model is DevOps, you're building microservices-based applications, deploying them in containers on the hybrid cloud, you should be backing them with software-defined storage, right? It all kind of goes together. It all is implemented as software. So what is software-defined storage? A lot of storage vendors, and raise your hand if you knew Red Hat was a storage vendor. I'm joking. A lot of storage vendors are talking about software-defined storage. But what does it mean? So I'll give you our definition of what software-defined storage is. The first thing is it's server-based. And what does that mean? I'll actually read this here. I don't like to read, but I'll read it. The use of software and standard hardware to provide services traditionally provided by single-purpose storage appliances. That's what we mean by server-based storage, and we believe it's one of the things that makes software-defined storage software-defined storage. Not everybody agrees. There are folks out there who have sort of orchestration systems that tie into a bunch of different storage systems on the back end, and they believe that orchestration is software-defined storage. But that's not what we mean when we talk about software-defined storage. We mean you're using regular servers and disks, standard servers and disks. We also believe that it requires some centralized control, because let's face it, if you're deploying across hundreds of machines. You can't be shelling into each one of them and running commands. You need to have some centralized control, and you need to be able to grow and shrink storage on demand and programmatically. It can't just be a web console. It can't. It has to be a fully featured web console, API, and command line that all have the exact same set of capabilities, and it needs to manage the entire thing, from provisioning all the way through to monitoring. So this is the second piece of what we think software-defined storage is. It's a system that has all of these things. And the third thing that we think is a piece of software-defined storage is that it has to have an open ecosystem. We believe this. And it's kind of logical. If you're building software that allows people to choose the hardware they want to deploy it on, you need to have all the partnerships around, and you need to have the ecosystem that supports that choice. And with Red Hat, we do that both by partnering with people on the commercial side and by having an open source foundation for it on the community side. So this is what we believe. Software-defined storage is server-based storage with centralized control and an open ecosystem. And it's the interesting thing about it, I'll kind of editorialize here. I often spend a lot of time thinking about the kind of person or the kind of organization that needs software-defined storage. And the parallel that comes to my mind most often is the kind of enthusiast who builds a PC. You know, I don't build PCs anymore. I just don't. I gave up. I've built PCs for years, and I was like, I did it. I no longer have a use case that requires me to do it because I don't game. But I know people who play a lot of games, or they do a lot of multimedia editing, or they want a very particular sound card because they have a studio, or they want to use DigiDesign stuff or whatever. They have a very particular reason, or they just need a monster machine. They need a machine that's bigger than anybody will sell them, so they build a PC. The same is true for software-defined storage. You do have to build it yourself. You got to go get all the parts and put them together. But when you do that, you can have capabilities that you can't get anywhere else. The ability to grow to multi-petabyte scale, the ability to choose the hardware that fits your workload best and gives you the performance that you need. So I often think about who is the right fit for software-defined storage, and it's a similar dilemma. It's a similar dilemma to that. So anyway, on to how can Red Hat help? Because of course we're Red Hat. And you're at Red Hat Summit. So how can Red Hat help? Well, the first thing is we have a Red Hat storage portfolio. How many of you are users of Ceph or Gluster? A few. OK, good. Finally, maybe you won't know more than I do in this section. We had a lot of storage people in here. So Red Hat storage is comprised basically of Red Hat Ceph storage and Red Hat Gluster storage. Ceph and Gluster are two software-defined storage technologies. They're very different, very, very different. If you've worked with them both, you know how different they are. They both do very similar things, though. Ceph and Gluster both have object, block, and file interfaces. They're both completely programmable. They're both self-managing and self-healing. They both have a whole bunch of hardware they can run on top of, but they're very different. Ceph takes a very complete approach to its architecture. Everything's configurable, lots of bells and whistles. It does very sophisticated things to make sure the data is safe at multi-petabyte scale. Not everybody needs those sophisticated things. Gluster takes a much more simple approach. Gluster, it's much more easy to set up. It has way fewer moving parts. It has way less overhead, and it has a smaller minimum node count. So in general, Ceph is used for very large-scale platforms, cloud platforms, giant object-stored platforms. Gluster is used for hyperconvergence, container convergence, scale-out NAS, and generally things that help applications scale out versus help infrastructure scale out. That's kind of how we see them differently, and it's because they've had completely different priorities. Ceph is fundamentally an object store. Gluster is fundamentally a file system. And that means that as you're figuring out how to solve this problem of scaling out with Gluster, you're doing that with a file system as opposed to an object store. It's a very different architecture. We run on top of a bunch of standard hardware. We have partnerships with all of these companies here. We release reference architectures with many of them to make it easier for people to understand what kind of performance they're going to get and that sort of thing. And it is our goal to support as many different types of hardware as we can. Because what's the point of software-defined storage if you only have a couple of choices? You need to have as many choices as possible. So we try to deliver those. Yes, sir? For some workloads, it might make sense to use local storage with OpenShift. I think it depends on how portable you want the containerized workloads, because if you move from a container host to another container host, the data might not go with you. If you deploy Gluster inside OpenShift, you can span it across multiple container hosts and make it so that containers are more portable. And I think there's good reasons to use a fully distributed scale-out file system for containerized workloads, and there's also good reasons to use local storage. So it's all about options. It's all about options. So we run on top of all this industry standard hardware, and we partner with as many ISVs as we can. We partner with as many software companies as we can to make it as full a solution as possible. One thing that's kind of key about both Ceph and Gluster is that they both behave like software. And this took me a while to get my head around, because you're like, well, you need to store it somewhere. Like, you know, how can storage be software? But it's the provisioning and the service layer on top of the physical hardware that is behaving like software. It makes it so that storage can scale like everything else in your data center scales and behave like everything else in your data center behaves, which is really powerful. And it also means that in the case of OpenShift, for example, a developer can deploy their own storage because it's just software. You know, they can deploy their own storage services. So it behaves like software. It's integrated into everything that we do. If you are interested in the differences between Ceph and Gluster, this is a really good roadmap. It shows that on the sort of physical location, of course, both Ceph and Gluster make sense on bare metal for different reasons. In a virtualized environment, we pair Red Hat virtualization with Red Hat Gluster storage. We believe that Gluster is the best thing to pair for standard virtualized environments. And the reason for that is because Gluster is a simpler architecture that hyperconverges more gracefully, right? In private clouds, Red Hat Ceph storage is what we prescribe for Red Hat OpenStack platform, because Red Hat OpenStack needs a unified storage platform. It needs something that does object, block, and file. It does something that scales out to a great degree, and Ceph is deeply integrated with OpenStack. So that's the one we prescribe there. Inside containers, we prescribe Gluster, and inside the public cloud, we prescribe Gluster. So in general, where you're talking about things that are close to the application, we prescribe Gluster, and things that are close to the infrastructure, we tend to prescribe Ceph. This is sort of how we see the world of Ceph and Gluster as it relates to different workloads within Red Hat. It offers pretty good value. Generally, over a traditional storage vendor, it's about half price with 12 drive bays. With 36 drive bays, it's about a third of the price. This is a throughput optimized configuration. So again, just like the whole PC thing, you can build the most cheap storage platform that's ever existed if you want. You could also build the most expensive storage platform that's ever existed if you want. But using sort of our recommendations, looking at a 3-year TCO, this is about 1 petabyte on a 2x replication. So this is kind of what it looks like. You can achieve really good economics with software-defined storage, particularly at petabyte scale. Red Hat, I was joking when I said, who knows, Red Hat's a storage vendor. But the funny thing about this is that Gartner considers us to be one of the more visionary storage vendors, and it's not even what Red Hat does exclusively. And the reason that Gartner thinks we're an interesting storage vendor is because we have all these other things, and we can do all these integrations, right? We can deliver a cloud platform that's tied really closely with storage, and a container platform that's tied really closely with storage. And of course, because we're Red Hat, everything has to be open. Ceph and Gluster are based on ecosystems that have a whole lot of contributions. So about 1,200 contributors to Ceph and Gluster combined, about 142,000 actual commits combined, about 5. So downloads are really funny. There's actually like 100 million downloads, so you try to like reduce the ones that come from build systems and stuff like that. This is a low watermark for downloads. It's about 5 million, at least 5 million downloads from actual people. And the people whose logos I've put up here are the ones who have committed to Ceph and Gluster. These are people who've actually committed code to Ceph and Gluster. And a lot of them are the hardware partners that we work very closely with. This is companies like Samsung making sure that, you know, their all-flash arrays scream with Ceph and Gluster. It's also companies like Facebook who contribute changes to Gluster because they've encountered scale things that nobody else will encounter, you know? And that's one of the benefits of having a good, robust upstream community. So I always like to leave people with things they can do to learn more. So what to do now? These are questions I would ask yourself if you're considering whether software-defined storage might be interesting to you. You know, what are you currently using? Does it scale flexibly and cost-effectively to petabyte scale? If you're at a petabyte and need to get to 2 petabytes, what does that involve? What does that mean? How much does it cost? What challenges are you facing? These are also questions you can ask your storage admins if you want. How do you manage provisioning? Is provisioning easy? Does it require going to a shipping dock? How do you manage capacity planning? What does migration look like? can you handle your needs next year with your current storage infrastructure? This is always a good question to ask yourself. And I know if you're a storage practitioner, you already know the answers to all of these questions. We do have a resource that I'd like to point out, which is our storage savings calculator, storagesavingcalculator.com. If you go to this, it's a very sort of rough calculator of, I have this much storage and this much growth rate, and here's my current costs, and here's my workload, and it'll tell you whether you're likely to save money with software-defined storage, particularly these software-defined storage solutions. It's an interesting resource. Give it a try. But since so many people in here raised their hands as practitioners, this is going to be way more interesting for you. The test drives. So Ceph and Gluster, like I said, they're kind of like building PCs. If you were to deploy it by yourself and just, take a day and deploy it, it might take you a half a day to get it up and running, maybe a day to get it up and running. A little bit of reading, find some hardware, pull together some VMs or something and get it together. We don't want it to take that long. So if you go to these URLs, fill out a couple of fields in a form, what we'll do is we'll set up Ceph and Gluster for you in Amazon Web Services, and we'll give you the keys, and we'll pay the bill, and we'll let it run for as long as you need it, and we'll give you about 6 hours of curriculum exercises to sort of illustrate to you how it works and show you all the different features. So I encourage you to go to these two URLs and try a Ceph and Gluster test drive if you're interested to see kind of how they work and how they behave. This is a really good way to get up to speed on it. Oops, really good way. So that's all I have for you. So thank you very much for your time. We're ending early on the last session of the last day, which is probably not entirely unwelcome. But I'm happy to answer questions for you if you want. I'll leave this slide on in case you want to go there. But questions? So the question is, if your network is not just some raging, amazing 40 gig network, does this still make sense to you? I think it depends on the workload, of course. You've got to do some calculations. It's not as fast as locally attached storage. I'll just say that. It's not tier 1 storage, and it probably won't be, It can be very fast if you're using flash intelligently. It can be very fast if you're using 40 gigabit. I know of people who have Ceph clusters, for example, that are all on 1 gig servers, and they just bought a whole lot of them, and they scale out the workload as much as they can. So I think it depends on the total combined IOPS you're looking for, how many servers you have, et cetera. I know it's a very unsatisfying answer, but it depends. The answer is, yeah, I know a lot of people who are running on a 1 gig. And it really just depends on the workload. I mean, it really does. What we tend to recommend is 10 gig with maybe 40 gig spines is what we tend to recommend. And networking is really important. So we do reference architectures with folks like Mellanox all the time to talk about how networking can affect it. So there's lots of benchmarking work going on there as well. So the question is there support for iSCSI in Gluster and Ceph? Not in Gluster. Ceph is positioning an iSCSI tech preview soon. So upstream, Ceph has iSCSI. The answer is we've tried that implementation a couple times. The first one we did not perform, and sometimes that happens. So we've gone back and implemented it again, and this one looks like it performs, and we're waiting for it to stabilize. So, I mean, generally, Red Hat likes to see upstream stability before we put stuff into our products, and with storage, it's even more important. So we really like to see how it behaves for a while. So if you want to get your hands on the bits, you can try them upstream. Downstream, I think we're looking for a tech preview of that in the coming months. What protocol does it support? So Gluster speaks NFS and Samba. Gluster also speaks Fuse. It's got a Fuse module, and it's got a Fuse, and I think it's got a native kernel module as well. Ceph, it depends on the interface. So Ceph Object speaks S3. It also speaks Swift, and it speaks Librados, which is Ceph's native protocol, which is wireline. It's got bindings in all kinds of languages. For the block device in Ceph, it supports what's called RBD, which is Rados block device. So it's a custom Ceph-specific protocol, but it has a kernel module and it has a user space library, and that's what's integrated into Cinder, Glance, and Nova for OpenStack. And that's where the iSCSI interface will be tied into, is Ceph's block interface. Ceph also has a file system, and right now, CephFS has a kernel module. So it's a native kernel module. And I think that there's a libCephFS as well, but I'm not sure how widely it's used. And there's no NFS or SMB on the CephFS side quite yet. So it kind of depends on the product and the interface, but yeah. Other questions? Cool. Well, thank you for coming to Summit. We really appreciate you joining us. Thank you.